Now we're on. We're rolling.
Excellent.
Yes.
So, first we're going to talk about comets, then we're going to talk about meteors.
Plan.
Sound like a plan? Okay, so a comet is a large ice ball. Comets are technically bigger than 1,000 meters. So, they're big balls of ice. Now, they can have rock in them too, and a lot of them do. Especially often the core, the middle, is made of rock, and you have a bunch of ice all around it. And these big chunks of ice are floating out there in the Kuyper Belt or the Oort cloud. And every once in a while, these things will hit one another. And just like a couple of pool balls, when a couple of pool balls hit one another, they can knock each other in different directions. And so they're just slowly orbiting out there, very far from the sun, some of them, especially the ones in the Oort cloud. And if they bump one another, one can get knocked toward the sun. One can get slowed down, and if it's orbiting and it slows down, it'll fall into the sun. And so they fall into the sun on this elliptical path. Ooh, it's dark. It's scary. It's Halloween. It's like it's Halloween.
Oh, yeah.
4th of July.
They fall into the sun on this elliptical path, and then they go around the sun and come way back out to where they kind of fell from, either in the Kuyper Belt or the Oort cloud. And you can see as they fall toward the sun, looks like a rock, but eventually, once it gets near the sun, it starts heating up. The sun's going to heat this up, and it forms a tail. There's two tails. One's called the gas tail, and one's called the dust tail. The gas tail is made of charged particles, ions, that are pushed away from the sun because the sun has charged particles coming off of it. The sun is constantly giving off a lot of protons and electrons that are flying into space. By the way, we have a name for that. It's called the solar wind. So the sun is constantly blowing off all these particles, and that's the solar wind. And the solar wind comes through and it hits this comet and pushes away these charged particles on the surface of the comet, get pushed away and form the gas tail. And also some dust particles from the comet get knocked off and form the dust tail. The dust tail kind of lags, just falls away from pushed away from the comet, and then makes kind of a curve. Because, do y'all remember I'm forgetting his name here, the laws of, not Newton. Kepler. One of Kepler's laws was, the further away from the sun you are, the slower you orbit. Y'all remember that? So when these particles get knocked off, they're going to orbit a little slower, and so they lag behind the orbit of the comet because they're pushed away from the sun. The further you are away from the sun, the slower you orbit. So you see this dust tail of particles that get knocked off the comet, and you see the gas tail, which are charged particles, like charged ions, charged atoms, that get really pushed away from the comet hard by magnetic repulsion. And they're just zooming away, so that forms kind of a straight tail. So you got the gas tail and the dust tail. This thing curves around the sun, and I want you to notice it's always pointed away from the sun, even when the comet's going this way. So in this way, the tail is leading the comet as the comet goes away from the sun. So you kind of, if you look at a comet up there in space, it's got a tail coming out from it, you're thinking it's going that way. Actually, if it's on the other side of the sun going back, the tail leads the comet. Do you see what I'm saying?
Yes, sir.
I have video showing it that you can tell a little bit better here.
As the comet nears the sun, its velocity increases as does the length of its tail, which always points away from the sun. Up close, tumblingly oddly shaped, comet nuclei resemble dirty snowballs.
Dirty snowball.
Its velocity increases as does the length of its tail, which always points away from the sun.
So see, it doesn't get a tail till it starts getting close to the sun. Did you see how the tail was leading it when it came around? Watch it again.
Wow.
Now, that's highly sped up. It's an orbiting body going around the sun. It might take 2 or 3 months to go around the sun like that. It does speed up when it gets near the sun. So wait, let's back this thing up. So from the time we start seeing the tail, there's the tail appears. This is when from Earth, let's say Earth is right here. This is when we can see it in the sky. And it might take months to go around the sun. Comets that we can see don't come about that often. Maybe one every 5 or 10 years that you can see with the naked eye. Now, if you have a telescope, you can see others better. And since it does go around the sun, you can't really see it when it's right near the sun or on the other side of the sun because it's out in the daytime. And you're not going to be able to see it in the daytime. So the only time you can see it, let's say the Earth was right here, is if it's away from the sun, if it's on the nighttime side. When it gets close to the sun, you can't see it with the naked eye, but if you had a telescope with a filter, you can see it, yeah.
Isn't there a comet named like Halley's Comet?
Yes, Halley's Comet is one.
Why is that so famous? Or
Halley's Comet, and that's what we're going to talk about next. Halley's Comet, there's a comet Hale-Bopp. That's another one that was in my lifetime. I don't think it was around for y'all. I think it was in the 90s. Halley's Comet is famous. It comes around every 76 years. It's on this path from the sun that comes from the Kuyper Belt, and it's on a 76-year orbit. And so it's seen every 76 years, and this guy named Halley discovered that. And he discovered it not by looking in the sky, he discovered it by studying history. Anybody here like history? This guy noticed there were writings about a comet. And he noticed that there were writings about this bright comet that appeared in the sky, and it happened, they wrote about it every 76 years. And he's the one that saw that. He said, look, this happened in 1256, and this happened in 1310, and this, and he added up the numbers, and it was always 76 years apart. And he said, it's the same comet. And he said, if that's true, if I'm right about this, it'll come back around in whatever year. And it was like 10 or 15 years later. And it did. And he had predicted it. So they named it Halley's Comet. Cool. Isn't that cool? Yeah. And it came around in 1986 when I was a senior, when I was y'all's age. And it's going to come around again. And what's 1986 plus 76?
2061.
2061.
Got a long ways to go.
So you guys will be alive for that. If I'm alive, I'm going to be real old. Here's what I want you to do. I want you to Facebook me, or whatever they have then, and go, Mr. Willis, Halley's Comet's back around. Are you still alive? And I'll go, yeah, I can say it. Okay, we all promise to do that?
Yes.
I'm going to try to live till then. That's one of my goals.
Wait,
Yeah.
how old will you be?
Like 95.
Oh my god.
Why does it Whatever the year.
Will it be like 50 years?
This is a great question Charlie's
Listen,
asking. Listen. This is a great question. Charlie says, why does a comet not melt? It does. So every time it goes around the sun, some stuff burns off of it.
Some?
Yeah, some stuff. So if you look at this You see, when it's going around the sun, it pushes away gas and dust, and the comet gets smaller. So comets, every time around, it gets smaller and smaller. So the comet will eventually disappear. And so Halley's Comet won't go around forever. But comets are pretty big. Like I say, they're at least 1,000 meters. That's as big as 10 football fields. So only a little bit burns off every time. So you might come around hundreds or thousands of times before it all burns up. Yes?
When you watch it, can you see it from anywhere in the world?
If it's on the right side, if it's not towards the sun, if it's towards the nighttime side, you can see it. If it's close enough and bright enough to be visible with the naked eye. And you go outside and you look, and it's like a little streak in the sky. It depends on how close it is, too. If it's closer, it's bigger in the sky. If it's farther, it's smaller in the sky. But I remember looking at Halley's Comet back when I was y'all's age, and I wasn't that impressed. It was a streak about longer than the full moon is, but thin, not as bright as the full moon. So it's a little streak in the sky about yay long. And I remember not caring much about anything back then, and my dad or somebody showed it to me, and I was like, yeah, great, okay, let's do whatever. And I just kind of looked at it just for a few seconds. And now I'm like, man, I wish I would have really looked at it. I didn't even like get binoculars or anything like that, which you could have done, or a telescope, looked at it up close.
Have you ever tried to land anything on a comet before?
Yes, they have.
Wait, how long is it visible in the sky?
It could be months. So you see it, and then it goes around the sun, and when it's toward the sun, you can't really see it, and then it's going away. So it's months, and it's slowly traveling. So you'll see it there one night, and then there the next.
Oh, that's
you see what I'm saying? It's out for a while.
That's super cool.
Yeah. Another one. This is Hale-Bopp, which was brighter than Halley's Comet, and this was a long period comet. Comets can come from if they come from the Oort cloud, they don't come around every 70 years or so. They come around every 1,500 years, or every 3,000 years, or every 10,000 years. So you're not going to see it more than once in a lifetime. They can compute the orbit of it. Once they see it and see how fast it's moving, they can compute where it came from. Video footage?
This animation is based on Hubble Space Telescope observations on the nucleus of comet Hale-Bopp. Astronomers unexpectedly caught the comet going through a sudden brief outburst, where in little more than an hour, the amount of dust being spewed from the nucleus increased at least 8-fold. The surface of Hale-Bopp's nucleus is an incredibly dynamic place, with vents being turned on and off as new patches of icy material are rotated into sunlight for the first time.
So here's the deal with this thing. Turn the volume off. So these comets, they rotate, and in space, if you're pointing towards the sun, it's hot. If you're pointing away from the sun, it's cold. If you're near the sun, it's hot. And so when a comet gets near the sun, it'll go from negative 200 and something Celsius to all of a sudden, it could be up to 50, 60, 70 degrees Celsius. That's a big change in heat. And when it heats up, the ice melts and it shoots away because there's not pressure and gravity holding it onto the surface. And the stuff just shoots away into space. It heats up and melts and turns into a gas and just shoots away into space. So that's why all this stuff comes on. And it'll, as the thing's rotating, it'll turn on and off. So the part that's in the sun will all of a sudden blast out a bunch, and then when it rotates out of the sun, it shuts off, it freezes again. And so you have this stuff spewing. It would be like geysers going off everywhere. If you could stand on the thing, there would be just stuff shooting off as it's rotating around. It would be a crazy place to be. Hey, Bob.
For centuries, comets have been considered harbingers of evil. By the end of the Middle Ages, a comet's appearance invoked fear and terror. But Renaissance scientist Edmund Halley, like Galileo, was interested in facts, not superstition. In 1695, he began searching for records of ancient and recent comet sightings. He found 24 comets whose passage across the sky had been recorded with enough detail to allow him to roughly plot their orbits. To his surprise, he found that 3 of the comets seemed to follow the same approximate orbit, circling the sun every 76 years.
On that basis, he figured, okay, this is a comet that's going to be back in another 76 years.
He figured out that the 3 comets were actually the same comet.
The same comet.
Halley was so certain of the comet's orbit that he made a bold prediction. He said the comet would return in the year 1758.
And guess what?
It was.
The comet came back.
Unfortunately, Halley was no longer alive to savor his discovery. Since then, Halley's Comet, as it's known, has been greeted 3 more times by excited skywatchers across the globe. No longer a harbinger of evil, Halley's Comet became a milestone discovery in the history of astronomy, replacing a superstitious belief with a rational scientific understanding of the physical universe.
Cool. I like Bill Nye. So, y'all seen this before. We have 2 things. We have the Kuyper Belt, which is where Pluto is. And some comets come from there. We call them short period comets. And then you have the Oort cloud, which is way outside the Kuyper Belt. And some comets come from there. We call them long period comets. So short period comets, like Halley's Comet, have periods of about 100 years, 200 years, somewhere in that value. They're falling from this area, they go around the sun, and they go back. Long period comets come from way further. There's the Kuyper Belt in there. Way further out is the Oort cloud. And those comets can have periods of thousands of years. And would only come around once every so often. So you asked, can we land on one? Was that your question, Sam? Yeah, actually, the European Space Agency did that. They launched a mission, it was called Rosetta, and it encountered a big comet. That's the comet. And it looked like a lion a little bit. And they landed this ship on it. It was called the Rosetta mission. And so there is a ship on a comet. Now, when they landed on it, it's not near the sun, so it's not lit up and firing gas off. It's just a big ice block floating out in space. It's rock and ice floating out in space. And they landed on that.
So it's on just a comet, like any particular.
It was a comet that was somewhat nearby.
No, yeah, so it just didn't have a name for it.
Yeah, there is a name. It's some long name with a bunch of numbers.
Okay, never mind.
So it's not coming back around that time soon?
No, it's. I'm not sure where in space it is right now, but
They wouldn't be able to land on one that was moving close to the sun, would they?
probably would be tougher because stuff's shooting off of it. So.
And be going faster.
This is a big block of ice. This is a cool picture. This is that comet next to Los Angeles, the city of LA. That's Los Angeles, and that's the comet. Just to show you the size.
So comets could hit us too.
Comets could hit us too,
Dang.
and they think it might have been a comet that hit us that was the one that killed the dinosaurs. They don't know if it was a comet or an asteroid.
And we haven't plotted all of those,
What would be the
correct?
difference?
No, and you never know. I mean, one could get knocked out of orbit, so new comets can come at any time.
What would be the difference? Like, which one would be more dangerous, a comet or an asteroid?
They could both be bad, depending on how big they were.
What's the
difference between
That's what I was about to ask.
Okay, a comet has mostly ice and water,
It's like
whereas an asteroid is mostly rock.
Wouldn't you?
Comets are usually big. Asteroids can be smaller. Yeah.
Wouldn't you find the material from the asteroid like in the Gulf of Mexico where it landed?
Well, they think it hit so hard it just blew up, and most of the rock or ice became gaseous, and then rained back down as water. The ice did, and the rock just kind of fell back down as dust. And they have found evidence of that, a layer of iridium all over the globe. Iridium is a heavy metal which is found in asteroids and comets. So
Dang it.
they don't know if it was an asteroid or a comet. Yes.
So if this is mostly ice, then wouldn't it go into hit Earth? Since, like the asteroid, it became really fiery, wouldn't it just all melt?
It's so big that it doesn't all melt before it hits. Our atmosphere is not that thick. So any object coming in to hit Earth heats up when it hits our atmosphere. But if it's traveling fast enough, it'll get through our atmosphere, hit the Earth before it melts.
Do a lot when they're orbiting near the sun, do they just melt off?
So it melts off of some of it, but a lot of it won't melt off.
So when it melts off, it'll be like kind of like it'll be getting crazy.
What's that?
Wait, so when it melts off, where's all of that going?
It goes into the air mostly as gas. It's like steam, and becomes part of the atmosphere. Does that make sense? Video footage? Yeah, there's rock and ice. Yep.
Yeah. Well, why doesn't it happen after
Rosetta steht dazu kommen, wir treten in vielfältig Steuern dieser Mission
Stay there, we orbited.
dann im November 2014 den Lander 4 abzusetzen. This is what we're looking at. 50% of the comets can be made of material like this. Possibly this water could have been delivered to the Earth by the comets, whether it's like sheet ice or it's more dusty ice. This is why we're going to this comet, to see where that water comes from, to see is it connected to Earth at all. The reason we're at this comet is for science. No other reason. We're doing this to get the best science, to characterize this comet as has never been done before.
We've spent years with the colleagues of the lander team, mainly colleagues from NES and DLR, to work out strategies, to redefine them, to train them all, to negotiate them, to fit all the constraints and the objectives for this operation phase. Now we have to implement it for real. Time has come to make it happen.
It landed already in November. Actually, November 2014, is that?
Yes.
But that was an old plane.
What have they found
there's a-
from that?
I don't know. That's a good question.
Also, how do they get that picture of, is it just an animation?
Of the comet?
Yeah, like on the PowerPoint, the side a couple minutes ago, you showed like a picture of the craft on the, yeah, that one.
Oh, that? Yeah. That's just an artist.
Oh, okay.
They have that, and they know what the comet probably looks like. So some artists made that. We've done other things. We've taken this is a NASA mission. It's called Project Stardust. We've taken a spacecraft. We've flown it behind a comet that was near the sun, shooting off gas and dust coming off of it. And this thing contained a substance called aerogel. Aerogel is a real life substance that that will capture the particles coming off of the comet. So this aerogel substance captured the particles. Then the spacecraft flew back to Earth, released the aerogel, so it re-entered the Earth's atmosphere in a container that had a parachute on it, and they floated it down to Earth, landed in the ocean somewhere, and a ship came and picked it up, and they studied the little particles that came from the comet. How cool is that? It's called Project Stardust. And so they have comet particles that they've studied up close. Now, the other thing this section talks about is meteors and meteoroids. A meteor is a particle from space that comes through our atmosphere. And have you ever seen a shooting star?
Yeah.
There's one right there. That's a meteor. Shooting star is a meteor. It's not a star. It's not way out in space. It's in our atmosphere. Our atmosphere is only about 10 miles wide. It actually extends much further than that, maybe 100 miles wide, but it's really only 10 miles. Is it thick enough where you can tell there's air there, and you can only breathe in it for about 5 miles up, and above that you need oxygen. But when a particle from space hits the Earth, or if the Earth hits a particle from space, the speeds are so great that the particle will burn up in the atmosphere if it's small enough, and give off a lot of heat and light, and even rock. It'll melt rock and turn rock into gas. And you see this as a shooting star. Most shooting stars are real tiny, like a grain of sand, that burns up in the Earth's atmosphere. Yeah?
Why did shooting stars normally go across the horizon? Like, you can't look straight up and see them normally. Like, I've heard people say, like, if you look across, like, that's when you see them. You don't see them, like, right above you.
Well, there's a lot more space across this way than there is right above your head. So you're more likely to see them down here because there's a lot more. You're seeing a lot more air.
They do go above you. It's just
they could go right above you. Yeah, I've seen them go right above you.
That's cool.
But usually you'll see them to the side just because there's a lot more to the side. There's a lot more area to the side. There goes one. They don't show it disappear. Somebody caught that on camera, I guess. The bigger it is, the longer it'll last. The longer it takes to burn up. Now, some of these things hit the ground. If they hit the ground, it's called a meteorite. If it makes it all the way through the atmosphere and doesn't burn up completely and it hits the ground, you're left with a piece of rock on the ground. That's a piece of a meteor. That's called a meteorite. A lot of these things have a lot of heavy metals in them. Meteors are made of rock, but they also have a lot of metal, mostly iron and nickel. But there are other heavy metals in them too. You can find gold, platinum, silver in meteorites. They're usually worth a lot of money. Have you ever seen the show Meteorite Men?
Never have.
It's about guys that take what are those things called? Metal detectors, and they go out in places and they try to find meteorites. And they find them and they sell them. They can be worth a lot of money. There's me next to a big meteorite at the Smithsonian.
Oh, yeah.
Science and Space. And that's what's left of a big meteorite that hit the ground. That would be worth millions of dollars.
Are there precious
And
metals?
Pat's worth millions of dollars. What's that?
Are there precious metals in that?
Yeah, oh yeah. That's mostly iron and nickel, but also there's some gold and stuff. Have you ever heard of a gold mine? There's a gold mine somewhere? Why is there a gold mine there? That's because that's where a meteor hit a long time ago and left all its metal. And there's some gold in there.
Meteorite.
Mm-hmm.
All the precious metals on the earth are found in the ground somewhere where a meteor once hit. long time ago, and it got all covered up by dirt, and it's down there. You just got to dig it up. There's been one person that's ever been hit by a meteorite. Her name was Ann Hodges. She lived in Alabama.
Oh, she's good.
And it came through her roof, and it hit her radio, and it broke apart. And she was in the room, and one of the pieces flew across the room and hit her side. That's her wound there.
Oh my God.
She's the only person that's ever been hit by a meteorite.
Is that like a bruise or?
That's like a big bandage cut there. Like a.
Oh my God. She lived and was able to tell.
She lived and was able to tell it. She's been in full recovery, and she's got the meteorite. It's worth a lot of money.
Oh,
I think she's dead now. That was 1954, so she might still be alive, but that was 60 whatever years ago.
No.
I don't know if she's still alive.
No, that's not that old. That's only like 60 something.
I'll find out.
60. She
That's
looks
not
like,
60 years ago. That's like
She doesn't look that young right there. I don't know.
55?
it's like 70 years.
My uncle was born in 55 and he's like
62
60.
years
Yeah,
ago, so she'd be like 80s or 90s probably.
It said, it just tell us about stories.
Yeah.
Doesn't tell she's alive?
No. I'll keep reading.
Go to Cyclacaga, Alabama, and you can see her house is still like
She
a.
died of kidney failure in 1972.
Aww. You get hit by a meteorite and then you die of kidney failure.
Yeah.
Well,
She's the only one that's ever been hit
I'll get you.
on the Earth. This is a crater. When meteorites hit the ground, they can leave craters, and this is the biggest crater that's in the United States. It's called Barringer Meteor Crater. It's in Arizona. It's a whole mile to go around this thing. It's a giant impact. It happened 50,000 years ago, before people were in North America. And this thing, a big rock came in and hit the ground and left this impact. Now, whenever one hits, it shoots what's called ejecta out of it and forms like a big mound all over the side where the stuff came out of the ground. Usually the meteor itself, the meteorite, breaks apart and there's not much left of it. A lot of it is immediately obliterated and becomes gas and floats out in the atmosphere and eventually comes back down. Yeah.
If you go to Arizona, are you allowed to go in that hole?
Yes, this was me and my dad. When I was 12 years old, we went out there and we went to the site, and that's what's left of it. It was a much bigger rock, but when it hit the ground, most of it is obliterated, and that's what's left of it. They have it sitting in a case. We took a picture of that. These are from old slides from my dad's old camera. And that's the hole, and you can hike around the rim. I think back then you could go hike down into it, but I think now they only let scientists down in there.
I'll get you.
That's so cool.
There's a little overhang back then. This was in the 70s, where you could go and look over the edge, take pictures and stuff. It's a big hole.
Wait, what's ejecta?
Ejecta is the stuff that comes out of the crater and goes everywhere. And usually it makes big mounds on the edge of the crater.
Where is the setting? Like, where are they letting people go?
I don't know. It might be dangerous, or that's a good question. This is a big, a famous site. It's called Tunguska. It's in Russia. And back in the early 1900s, a big meteor hit there and knocked over all the trees for thousands of meters in all directions. And it was one of the bigger meteor impacts, this Tunguska impact.
Do you think it causes an earthquake?
It causes an explosion, and it can be a nuclear explosion because the impact is so great. And here's how often that sort of thing happens. A Tunguska event only happens, once a millennium or so, once every 1,000 years. But greater than that, every 10 million years, you get an impact that is 100 million megatons TNT equivalent. So that's enough to kill the dinosaurs.